Okay guys, today we're going to review some skills you learned in Algebra 1, factoring special cases. These are the easier factoring problems. So we're going to review first with these and then we'll move on to factoring certain trinomials. We're going to start with the difference of two perfect squares. As the name says, we will have two perfect squares. So we have a squared minus b squared. That would be the difference of the perfect squared a and the perfect squared b. When we factor these, they factor very quickly into a minus b, a plus b. Notice the middle terms, positive ab and negative ab, cancel out, leaving us just with two terms when we multiply them of a squared minus b squared. So here's some examples. We have here x squared minus 81. We factor it into two binomials, x minus 9 and x plus 9. We can do this because, again, the middle terms cancel out. Here's a second example, 4x squared minus 9. What we're looking for in each case, we have to make sure that's a perfect square and that's a perfect square. As we notice, 4x squared is actually 2x times 2x, and 9 is 3 times 3. So we have 2x times 2x, and then we have a minus, and one's a plus, and then we put our 3 and our 3 in. Once again, we notice that the two middle terms are going to cancel out. That is why we do not have a middle term in our difference of two squares. Here's a third example. Once again, we have a perfect square of 16 and 49. So that's going to give us 4x times 4x, which gives us 16x squared. One's a minus, one's a plus, and then the square root of 49 is 7, so we have 7 times 7. One thing that's important to remember is that the sums of perfect squares do not factor. They do not factor, so please do not try to factor the sum of perfect squares. Now we're going to look at perfect cubes, the sum or the difference of two perfect cubes. When we're dealing with perfect cubes, we can have the sum or we can have the difference like we did in perfect squares. Here's our first example, x cubed plus 8. It is the sum of two perfect cubes. The cubic root of x cubed is x, and the cubic root of 8 is 2. So we start off by writing x plus 2. The perfect cube of x cubed is x, and the perfect cube of 8 is 2, and we just bring down our plus sign. Next, we're going to have a trinomial that we multiply this binomial by. The first part is x squared because x times x squared would give me the x cubed. Then the back part is 4 because 4 times 2 gives me the 8. Now we have to be able to get rid of middle terms. So what we do is we multiply these two together, which gives us positive 2x, and then we put the opposite in the middle of our trinomial, negative 2x. So we have successfully factored the sum of two perfect cubes. So let's try another example. Here is 8x cubed minus 27. This is the difference of two perfect cubes. Notice the cubic root of 8x cubed is simply 2x. And the cubic root of 27 is 3, because 3 times 3 is 9, times 3 is 27. Then we have to have our trinomial. So we have 4x, because 4x times 2x is 8x cubed. 4x squared, times 2x is 8x cubed. Our back term is going to be 9, positive 9. 9 times 3 is 27. Note that the last term will always be positive, and the middle term will be the opposite of the term, the operation in the binomial. So we will multiply 2x times negative 3, which gives us negative 6x, and the opposite value, positive 6x, will go in the middle. We have now factored the difference of two perfect cubes. We can't factor this trinomial any further. Here's another one. So our first term is 27x cubed plus 64. So the cubic root of 27x cubed is 3x. And the cubic root of 64 is 4. And we just bring down our positive, put our 4. Then we're going to have another trinomial, 9x squared, because 9x squared times 3x is 27x cubed. Remember, the last term is always positive. And then we're going to have 16, because 16 times 4 is 64. And then once again, we multiply the two terms in the binomial together, which is 12x, and we put the opposite as the middle term of the trinomial. Our last special case is perfect square trinomials. These will be trinomials that are multiplied, that when factored, give you a binomial that's multiplied by itself. So let's look at an example. X squared minus 6x plus 9. Our first thing to notice is that if we take half of the middle term, half of 6 is 3, and square it, we would get the last term. So this is going to factor x, and then we bring down our minus 3, and then we're going to have x minus 3. So we bring down the first operation, and we know it's x minus 3 times x minus 3, which gives us x minus 3 squared. Hence the perfect square trinomial, because it comes from a perfect squared binomial. Here's another example. 4x squared plus 28x plus 49. We know the square root of 4x squared is 2x, and the square root of 49 is 7. If we multiply 7 times 2 together, we get 14. Doubling it, we will get our middle term, 28x. So this is a perfect square trinomial. So we factor it into two binomials that are exactly the same. 2x plus 7 and then 2x plus 7. This gives us a binomial that is squared. So we have 2x plus 7 squared. So that's our three special cases. The difference of two perfect squares, the difference or sum of two perfect cubes, and a perfect square trinomial. We'll do some practice problems tomorrow in class. See you then.